1984 Philips spins off ASML, creating a tiny Dutch tech company. Advanced semiconductor materials lithography quickly becomes key player in semiconductor industry. Its mission, print computer chips smaller than human hair with precision. Competitors like Nikon Canon fail to reach ASML's EUV capabilities. ASML now controls over 90% of high-end photolithography market. Revenue exceeds $30 billion annually, employing 40,000 worldwide. Photolithography uses light to etch circuits onto silicon wafers with incredible accuracy. Extreme ultraviolet light EUV penetrates circuits normal light cannot reach. Each EUV beam travels inside vacuum to avoid contamination. Mirrors larger than cars reflect the beam with atomic-level precision. Robots adjust movements hundreds of times per second inside these machines. Each wafer exposed dozens of times to build microchip architecture. Chips power phones, laptops, AI servers, and advanced military hardware. Without EUV machines, modern technology halts almost entirely. Decades of research, billions of investment required to develop EUV. Competitors Nikon Canon fail repeatedly, leaving ASML as only supplier worldwide. By 2019, ASML becomes a geopolitical chess piece. United States pressures Netherlands to restrict ASML EUV exports to China. Donald Trump personally intervenes, calling Dutch Prime Minister Mark Rutte. Contracts worth billions are frozen under international scrutiny. Each EUV machine costs approximately $150 million. Machine assembly takes years, involving thousands of engineers across dozens of countries. A single machine can redefine a semiconductor company's capabilities overnight. Biden administration reinforces export restrictions in 2024, keeping ASML as leverage. ASML now central to global semiconductor Cold War. US and Europe use ASML to limit China's advanced chip access. China invests over $100 billion in domestic chip development programs. Even TSMC, Samsung, Intel, Apple depend on ASML EUV machines. China remains years behind in high-end chip production without EUV. EUV precision requires lasers, mirrors, and robotics accurate to atoms. One mistake destroys an entire silicon wafer instantly. ASML machines act as strategic leverage in global tech diplomacy. Every export contract reviewed by Dutch and US government agencies. Delays ripple across supply chains worth billions of dollars. Advanced chips critical for AI, quantum computing, and military applications. China's reverse engineering efforts ongoing but progress slow and expensive. European governments tightly regulate EUV exports due to national security concerns. Stock markets react to ASML news showing global influence. Intel, AMD, Nvidia, and TSMC depend on EUV for next-generation chips. Without EUV, AI chip production would stall dramatically. ASML journey shows innovation can shift global power balance. Technology alone becomes both economic asset and strategic weapon. The Netherlands gains outsized influence due to ASML's location. US guides policy controlling who accesses these machines globally. Even Apple and Nvidia track ASML announcements as critical intelligence. Machines represent decades of innovation, billions of investment, and human expertise. Tiny Dutch company now dictates speed of global semiconductor development. ASML machines are the ultimate bottleneck for advanced chip production. China's attempts to catch up face technical and financial hurdles. Export restrictions prevent EUV machines reaching Chinese companies directly. Advanced chips now essential for military, AI, cloud computing, and high-tech industry. Every ASML shipment impacts geopolitical calculations between US, Europe, and China. EUV technology defines the modern chip race and global competitiveness. Billion-dollar projects depend on timely delivery of these machines. Each machine is a masterpiece of engineering precision and international collaboration. Competitors fail to replicate EUV, maintaining ASML's monopoly. Machines cost $150 million each and take 3 to 4 years to build. Laser precision measured in nanometers beyond human perception. Each EUV wafer a tiny miracle of science and engineering. China invests heavily in domestic alternatives but remains years behind. Even one delayed machine can halt entire AI chip production lines. US and Europe coordinate on strategic access and export policy. Every machine shipment monitored for compliance with international regulations. ASML becomes geopolitical leverage without firing a single shot. Dutch Prime Minister Mark Rutte personally oversees sensitive export approvals. US Department of Commerce restricts licenses, preventing sales to certain countries. Intel, AMD, TSMC, Samsung, Apple rely on these EUV machines. Advanced chips shape global AI research and military technology development. Machines produce chips powering autonomous cars and next-generation computing. Without EUV, China remains technologically dependent for high-end chips. Even routine EUV shipments affect billion-dollar semiconductor projects worldwide. ASML dominance proves industrial mastery can redefine international influence. High-precision mirrors and lasers require collaboration across dozens of countries. Assembly takes years under strict cleanroom protocols. Each machine represents hundreds of millions of dollars in research and labor. Stock markets react instantly to ASML geopolitical news. Companies compete for EUV machine allocation globally. Machines become central to the semiconductor supply chain strategy. China continues to invest billions in domestic lithography research. Europe and US maintain regulatory control to protect strategic advantage. EUV machines remain impossible to replicate without decades of expertise. Every chip depends on ASML for next-level computation. AI quantum computing and advanced defense rely on EUV-enabled chips. The US and Netherlands coordinate to prevent technology transfer. Export restrictions ensure China cannot access most advanced EUV machines. ASML now central to the global chip Cold War. Without their machines, high-end semiconductor production stalls immediately. Even minor machine delays affect billion-dollar contracts worldwide. Each wafer process demonstrates mastery of lasers and robotics. Machines cost over $150 million and require thousands of parts. EUV machines are both engineering marvels and geopolitical weapons. Companies like TSMC and Samsung schedule production around EUV availability. The Netherlands gains enormous strategic leverage globally thanks to ASML. The story shows how technology can wield influence without military power. Every contract becomes a delicate negotiation involving US, Dutch, and Chinese officials. Advanced chips now define national competitiveness in AI and military hardware. ASML dominance ensures Europe and US maintain a critical technological edge. Machines shape the future of computing and global strategy simultaneously. Every wafer printed represents billions of dollars in economic and strategic value. China invests heavily but remains dependent on foreign expertise. Even Apple, Nvidia, and Intel monitor EUV shipments closely. ASML represents a unique intersection of technology, economics, and geopolitics. Advanced chips power modern AI, cloud computing, and autonomous systems. Export controls reinforce US and European technological advantage over China. Every EUV shipment has implications for global semiconductor balance. ASML engineers may not hold guns but influence global power profoundly. This tiny Dutch company dictates the pace of modern technology. EUV machines have become ultimate bottlenecks and leverage in geopolitics. The semiconductor world revolves around $150 million marvels of engineering. Who will dominate next-generation chip production remains uncertain. ASML continues to lead, controlling supply and shaping geopolitics. Every machine, every wafer, every contract matters for global power. Stay tuned for the next chapter in the semiconductor Cold War. Like and subscribe for more cinematic stories of technology and power.